In this video, I'm going to show you how to calculate empirical and molecular formula from its composition. So to calculate the empirical formulas, you just need to find the lowest whole number ratio. So in a molecule like this, C6H12O6, all of those numbers are divisible by 6, so I can reduce it down to CH2O. And something like CH4N, there's not a single number I could divide them all by to reduce it down, so it's already in its lowest ratio. So a formula is not just the ratio of atoms, it's also the ratio of moles. So in 1 mole of carbon dioxide, there's 1 mole of carbon and 2 moles of oxygen. And in 1 molecule of carbon dioxide, there's 1 atom of carbon and 2 atoms of oxygen. So we can get a ratio from its percent composition. So first you need to assume that you have a 100-gram sample of the substance. The problem's probably not going to say this, but it's always safe to assume in this type of problem that you're starting with a 100-gram sample. When you do this, the percentage becomes grams. So if I said you had 75.1% of a certain element, it means you have 75.1 grams of that element. Your next step is to convert from grams to moles, and we've been practicing this chapter by using our molar masses off the periodic table. Then you need to find the lowest whole number ratio by dividing each number of moles by the smallest value to find the ratio of all the values to each other. So here's an example. Calculate the empirical formula for a compound composed of 38.67% carbon, 16.22% hydrogen, and 45.11% nitrogen. So step 1 is to assume we have a 100-gram sample. So that means I have 38.67 grams now of carbon, and I need to convert that into moles. So in 1 mole of carbon, remember I have 12 grams of carbon. So grams and grams will cross off, and I'll get 3.22 moles of carbon. So next we need to do the same thing for hydrogen. So instead of 16.22% hydrogen, if I assume I have 100 grams, I have 16.22 grams of hydrogen. So I need to convert from grams of hydrogen to moles of hydrogen. So I need to just divide by the molar mass of hydrogen right off the periodic table. 1 mole of hydrogen weighs 1 gram. So 16.22 divided by 1 is 16.22 moles of hydrogen. And then last, I need to do the same thing for nitrogen. Assuming I have 100 grams, that means I have 45.11 grams of nitrogen. And nitrogen weighs 14, so I'm going to divide by 14 grams. So grams and grams will cross off, and that will convert to 3.22 moles of nitrogen. So our next step is to find the ratio of all of these moles. We need to divide all of them by the lowest amount. So I have 2 that are tied here, 3.22, so it doesn't matter which one you pick. I'll pick nitrogen. We're going to divide each value by nitrogen. So 3.22. So the ratio is 3.22 moles of carbon divided by 3.22 moles of nitrogen means that for every 1 mole of carbon, I have 1 mole of nitrogen. So let's do the ratio of hydrogen to nitrogen. So I have 16.22 moles of hydrogen divided by 3.22 moles of nitrogen will give me 5 moles of hydrogen for every 1 mole of, 5 moles of hydrogen for every 1 mole of nitrogen. And there's no reason to do it for nitrogen because it would just be 1. So for every 1 mole of nitrogen, I have 1 mole of nitrogen. It wouldn't make sense to do it. So I'm just going to apply these numbers here into my formula. So I have 1 mole of carbon, so that will go here. I have 5 moles of hydrogen, so that will go there. And I have 1 mole of nitrogen, so that will go there. So here's my empirical formula, CH5N. So let me show you a special example. If I had a compound that was 43.64% phosphorus and 56.36% oxygen, what is the empirical formula? So our first step is to assume we have 100 grams, so those percents become grams. 43.64 grams of phosphorus. And then we need to convert that into moles for step 2. So in 1 mole of phosphorus, we go to the periodic table and we'll see that phosphorus weighs 31 grams per mole. Now grams and grams will cross off, We'll convert to moles of phosphorus and we get 1.4 moles of phosphorus. Let's do the same thing for oxygen. I have 56.36 grams of oxygen. Oxygen weighs 16, so I'm going to divide by 16. 56.36 divided by 16. Grams of oxygen and grams of oxygen will cancel, which means I will get 3.5 moles of oxygen. So far, so good. The last step is to divide each by the lowest amount to get the ratio. And the lowest amount here this time is 1.4. So the ratio of moles of oxygen to phosphorus would look like this. 3.5 moles of oxygen divided by 1.4 moles of phosphorus. If I do that math, I would get 2.5 moles of oxygen for every 1 mole of phosphorus. So when you plug in your empirical formula here, you might want to say P1 2 or O 2.5, but this can't happen. You can't have 2.5 moles. You can't have a half a mole of anything. So another mistake would be to round up to 3 and say, oh, well, the 5 would round up to 3. It wouldn't work this way either. Actually, in these scenarios, we would multiply everything by 2. So the answer would be P2O5. And this only happens when you get exactly half a mole in your ratio. Okay, one more example here. I would like you to do the first part on your own. So go ahead and pause the video and copy these numbers down. Follow the steps that we did on the last 2 problems to find the empirical formula for caffeine, which is made of carbon, hydrogen, nitrogen, and oxygen. When you're ready, unpause the video and I will solve the rest. Okay, here we go. I have 49.48 grams of carbon, 5.15 grams of hydrogen, 28.87 grams of nitrogen, and 16.49 grams of oxygen. And I've gotten these numbers by simply assuming I have 100 grams, and all of these percents just turn right into grams. Step 2 is to convert to moles. So I'm going to divide each of them by their molar mass. So I go to the periodic table and see that carbon weighs 12. So 49.48 divided by 12. Hydrogen weighs 1, which would be 5.15 divided by 1. Nitrogen weighs 14, so I'll do 28.87 divided by 14. And oxygen weighs 16, so I'll do 16.49 divided by 16. These numbers will all cross off to solve for moles, which is what I want to do in step 2. And I'll get the answer of 4, 5, 2, and 1. Now you can round to get a nice whole number. Like if I divide 16.49 by 16, I know it's not going to be 1, but you can round, it's fine. So my last step is to divide each number by the lowest one to find the ratio. And this is going to be really easy because the lowest one is 1. So 4 divided by 1 is 4, 5 divided by 1 is 5, and 2 divided by 1 is 1, and 1 divided by 1 is 1. So the empirical formula is kind of right here in front of us. C4, H5, N2O. So since the empirical formula is the lowest ratio, the actual molecule would weigh more, and it's going to do so by a whole number ratio. So to go from the empirical formula to the molecular formula, you need to divide the actual molar mass by the empirical formula mass that you get just by looking up the mass of all the elements in your empirical formula answer. When you do that, you're going to get a whole number. And what you need to do next is increase each coefficient in the empirical formula by that number to get your molecular formula. So let's keep with this caffeine example. Caffeine has an actual molar mass of 194 grams. So what is its molecular formula? So remember, we found the empirical formula to be C4H5N2O. The actual molar mass divided by the empirical formula mass is going to give us the factor that we may or may not need to up our empirical formula by. So the actual molar mass is in the problem. They said it's 194 grams. The empirical formula mass you need to figure out. So that would be the mass of all of the elements in your empirical formula. So I have carbon, and I have 4 of them. So 12 times 4 is 48 grams. Next, I have hydrogen, and I have 5 of those, and they each weigh 1. So 1 times 5 is 5 grams. Then we have nitrogen, which weighs 14, and I have 2 of those, so 14 times 2 is 28. And I have 1 oxygen, which weighs 16, so that's just 16. If I add up all of these numbers here, 48, 5, 28, and 16, I get 97 grams. So the empirical formula mass is only 97 grams, so I know that's not the molecular formula. So I divide those numbers and I'll get a factor of 2. That means my empirical formula is off from my molecular formula by a factor of 2. So all you need to do is multiply your empirical formula by 2 to get your molecular formula. So our molecular formula will be C8H10N4O2. So let's wrap things up here. So to calculate the empirical formula from the percent composition, follow the 3 steps. Step 1 is assume you have 100 grams. When you do that, those percents that they give you in the problem become grams. Step 2, convert from grams to moles, and you do that just by dividing by the molar mass off the periodic table. Then we divide all the values by the smallest number of moles, and that will get you a ratio, and that ratio will give you the empirical formula. Remember, an empirical formula is a whole number ratio, and if you get a ratio that ends in 0.5, multiply every number in your ratio by 2 to get the correct ratio. So to calculate the molecular formula from the empirical formula, also follow 3 steps. First, you got to find the empirical formula, and then you need to divide the actual molar mass by the empirical formula mass. Then multiply every number in your empirical formula by this number and you'll get the molecular formula. Every once in a while you'll get a problem where if you divide the actual by the empirical you'll get 1, which means that your problem is already an empirical formula and the answer just is the empirical formula. So I hope this makes sense to you. If you have any questions, please let me know. I know this is kind of a long, convoluted type of problem. This is going to take some practice and getting used to. But if you do enough of these, they become really easy.